Welcome to the deep dive, where we sift through the latest research and ancient discoveries to give you that essential shortcut to being truly well-informed.
It's great to be diving in.
Today, we're tackling a really deeply ingrained image, one that I think most of us carry around when we think about where we come from.
Hmm.
We tend to visualize human evolution as this, neat, predictable linear ladder,
I
right?
have that classic image, the March of Progress.
Exactly. A straightforward march, rung by rung, from some distant ape-like ancestor all the way up to us, modern humans, perched at the very top.
Always at the top, naturally.
But what if that story, that comfortable mental picture, is actually far more complex, filled with unexpected detours, fascinating dead ends, and, well, a whole lot of parallel paths that were simultaneously exploring what it meant to be something new?
It's truly remarkable how stubbornly that linear ladder image persists, in popular consciousness, despite decades, literally decades, of paleontological discoveries screaming a completely different narrative.
It's easier, I suppose.
It's an easier story to tell ourselves, certainly a simpler progression, but it's fundamentally inaccurate. And I think critically, it prevents us from appreciating the true ingenuity, the sheer diversity, and the sheer number of evolutionary experiments our ancestors undertook.
Right.
We miss the richness of our past when we cling to that single line.
That's precisely the challenge we're diving into. In this deep dive, our mission is to kind of peel back the layers on some absolutely fascinating new insights and ancient discoveries. Things that reveal our human family tree is less of a rigid ladder and much more of a wild, sprawling bush.
A bush, yeah, or maybe even a thicket.
A dense thicket, I like that.
Uh-huh.
A thicket of experimentation and some truly surprising adaptations. We'll explore how these recent finds are not just adding to our understanding, but fundamentally revolutionizing what we thought we knew about our lineage and, indeed, what it genuinely means to be human.
Exactly. It's a journey into, well, radical rethinking, really, where what we previously considered foundational truth about our origins are being revised, sometimes quite dramatically.
So not just tweaking the details.
Oh, no. We'll see that the very essence of our lineage isn't about a singular, inevitable progression towards Homo sapiens, but rather a continuous process of trying out diverse approaches to life, to locomotion, to survival, and even, amazingly, to symbolic thought. It's a testament to the power of evolution to explore, like, every conceivable niche.
And we're going to introduce you to some truly incredible early human species that will likely challenge everything you thought you knew.
Some real curveballs in the fossil record.
Definitely. We're talking about a potential biped from 7 million years ago, found in a place, honestly, no one ever expected.
Still debated, but yeah, potentially that far back.
Then we'll encounter a woodland dweller whose skeletal structure completely upended our theories on why bipedalism evolved in the first place.
A real paradigm shift, that one.
And finally, we'll delve into the astonishing case of tiny-brained beings who performed complex, coordinated rituals. Rituals that would make you seriously question the very definitions of intelligence, community, and maybe even consciousness itself.
That discovery really sent shockwaves through the field.
So prepare for some serious aha moments, because you're going to gain a deeper, more nuanced appreciation for our evolutionary journey. You'll understand that the very essence of being human isn't about reaching some predetermined peak, but rather lies in a relentless drive to adapt, to innovate, and to experiment with what's possible. We're going to show you why every new fossil discovery isn't just an isolated bone. It's like a brand new chapter in our collective story, often rewriting the previous ones in the most spectacular ways.
And it's often these new chapters, the ones that defy our expectations, that are the most compelling, aren't they?
Absolutely.
They force us to abandon comfortable assumptions and embrace a more dynamic, intricate past. And this isn't just about ancient history. It's about understanding the deep, evolutionary roots of our own species' incredible capacity for change and ingenuity, a capacity that continues to define us today.
Okay, let's unpack this then. Let's start at the very beginning of our divergence, or as close as we can get. When we typically conjure an image of early human ancestors, the setting, it's usually East Africa, right?
That's the classic picture, yeah. The Great Rift Valley.
The Great Rift Valley, exactly. With a timeline that seems to march forward predictably. That's been the conventional wisdom for so long. But what if the very first steps towards bipedalism, that fundamental defining shift to walking on two legs and some of our absolute earliest relatives, were found in the most unexpected places, completely disrupting our mental maps and forcing us to reconsider, well, the very birthplace of humanity.
That's a great way to frame it because one of the most consistent themes in paleoanthropology over the last few decades is how the earliest evidence of bipedalism continuously pushes back the timeline.
Further and further back.
Further and further back, exactly. And perhaps even more surprisingly, significantly expands the geographic scope of where early hominins were found. It forces us to question our deeply ingrained preconceived notions of where and, crucially, why these critical evolutionary shifts occurred.
So we weren't just huddled in one corner of Africa.
It seems not. We've been so focused on East Africa as the cradle of humanity. And look, it's incredibly important, don't get me wrong, but the story is clearly much, much bigger, spanning a far wider landscape than we initially thought.
And that's where our first extraordinary ancestor, Tumai, comes into play. This incredible discovery, formerly known as Sahelanthropus tchadensis, was a true game changer, not just for its age, but for its location. It was found in Chad, in the Searing Sahel region of Central Africa, way back in 2001.
Right, Central Africa, not East Africa.
Exactly. Now, just the location of this find was a profound shocker to the scientific community. Paleontologists had largely concentrated their search for early hominin species on our direct lineage after the split from chimps almost exclusively in East Africa's Great Rift Valley.
That's where all the action seemed to be.
So finding something so potentially pivotal thousands of miles to the west, far removed from the expected hot zone, was, well, it was nothing short of mind-boggling.
The analogy often used, and it's a good one, to convey the sheer surprise of this discovery is that it was like finding the first car in Antarctica.
Huh. Okay, that paints a picture.
It completely upended expectations about early human dispersal and the geographical boundaries of our origins. For decades, the consensus was forming around East Africa, and then Tamai basically said, think again.
Right.
It immediately opened up questions about whether the common ancestor was more widespread, or if bipedalism evolved independently in multiple regions, which would be amazing, or maybe if dispersal occurred much, much earlier than imagined.
So lots of new possibilities.
We thought we knew where to look, and Tumai told us we needed to expand our view significantly, potentially across the entire continent.
And what Tumai revealed about itself was even more remarkable than its unexpected address, wasn't it?
Absolutely. The fossil itself.
This partial skull dates back about 7 million years. Just let that sink in for a moment. 7 million years ago.
Right near the estimated split time.
This places it firmly at the very root of the human lineage, right around the time our ancestors are thought to have diverged from the ancestors of chimpanzees. It's a fossil that sits right at that pivotal fork in the road.
A crucial point in time.
But it wasn't just ancient. It had some truly distinctive traits that suggested its place on our side of the family tree. For instance, Tumai possessed tiny, flat canines. Now, this is a seemingly small detail, but it's incredibly significant.
Hugely significant.
Because it's very different from the prominent, pointed, interlocking fangs you'd find in apes, which are often used for display and aggression. Reduced canines are a hallmark of later hominins.
That reduction in canine size is indeed a crucial piece of the puzzle, hinting at changes in diet, maybe, or social behavior. But for definitively placing Tumai on the path to humanity, the most compelling evidence, though still debated by some, came from the placement of the foramen magnum.
Right, the hole at the base of the skull.
Exactly. That's the large hole at the base of the skull where the spinal cord exits to connect with the rest of the body. Now, in quadrupeds, animals that walk on 4 legs, this opening is typically positioned towards the back of the skull, allowing the spine to extend horizontally, parallel to the ground.
Makes sense.
However, in Tumai, the foramen magnum is located more centrally beneath the skull, more forward.
Ah, so underneath, rather than at the back.
Precisely. And this particular positioning is a strong indicator, not definitive proof, but a strong indicator of a possible upright posture, because it would have allowed the head to balance directly on top of a vertical spine, which is a key anatomical feature of bipedalism in humans.
So the head's balanced for looking forward while upright.
It suggests that this individual wasn't looking forward while walking on all 4s, but rather looking forward with a skull balanced on an upright spine.
So if this interpretation holds, and I know there's still some discussion.
There is, yes. You need more than just a skull, ideally.
But if it holds, this single discovery profoundly challenges the prevailing idea that early human evolution, and specifically the emergence of bipedalism, was solely confined to East Africa.
It blows that idea open.
It opens up possibilities for multiple centers of origin across the African continent, or at the very least, much wider and earlier dispersal of bipedal forms than anyone had previously envisioned.
Right. Or maybe the common ancestor was already experimenting with upright posture before the split. Lots of questions.
And this early, even if tentative, hint of upright posture also means that bipedalism could be significantly older than previously thought, pushing that foundational adaptation back millions of years further into our past, right to the very cusp of our lineage.
It strongly suggests that walking on 2 feet might have been an evolutionary experiment that started almost as soon as we diverged from other apes, not something that arose much later, perhaps under different pressures.
Wow.
Precisely. It signals a much broader stage for early hominin evolution, suggesting that the initial conditions or selective pressures for bipedalism weren't restricted to a single geographical hotbed, and that this trait began to emerge at the very earliest stages of our split from a common ancestor with chimpanzees. It's a testament to the exploratory nature of evolution, immediately trying out this new form of locomotion.
So Tamai gives us a fascinating glimpse, maybe the earliest glimpse, into the potential steps towards upright walking, hinting at a much more ancient and geographically diverse origin for this critical trait. But if bipedalism was being experimented with so early, what did it look like when it was a more fully formed adaptation? And maybe more importantly, what did that tell us about why it emerged in the first place?
Exactly, because Tumai is provocative, but still quite fragmentary.
This brings us to a woodland walker who absolutely shattered decades of entrenched evolutionary theory.
That's where Ardi, or Ardipithecus ramidus, enters the picture. Ardi, who lived about 4.4 million years ago in Ethiopia.
Okay, so back in East Africa now.
Back in East Africa, yes, but about 2.6 million years after Tumai. Ardi truly overturned one of the most entrenched theories in paleoanthropology with her unique mosaic combination of traits. She forced us to fundamentally reconsider the environmental pressures that drove us onto 2 feet.
Ardi was discovered in the Afar region of Ethiopia, a site that, it's just yielded an incredible wealth of hominin fossils.
A treasure trove.
And she gives us an extraordinary window into what life was like for our ancestors over 4 million years ago. She stood about 4 feet tall, so a relatively modest stature.
Taller than us, yeah.
But it was her physical blend of features that truly stumped and ultimately enlightened researchers. Ardi had grasping feet, much like an ape, with a divergent big toe.
An opposable big toe, like for grabbing branches.
Exactly. Perfectly adapted for climbing trees. But here's the kicker. Her pelvis and the structure of her upper thigh bone were clearly adapted for upright walking. Not just possible, but quite capable.
So, a walker and a climber.
This was a creature comfortable both navigating the canopy and moving efficiently on the ground. A true hybrid in terms of locomotion.
And her hands were equally telling, weren't they?
Yeah, tell us about the hands.
While they were suited for climbing, flexible wrists and fingers, they showed no signs of the robust wrist and knuckle adaptations seen in chimpanzees and gorillas.
So not a knuckle walker like chimps.
Definitely not a knuckle walker. This suggests a very different evolutionary trajectory from other great apes right from the start. This mosaic of features grasping feet for trees, bipedal pelvis for the ground, and non-knuckle walking hands paints a picture of a truly versatile inhabitant of a mixed forest and woodland environment.
Not the open grassland we always imagined.
Exactly. Not an open grassland specialist. She could move both vertically and horizontally with ease, combining arboreal and terrestrial locomotion in a way we hadn't really seen crystallized before.
What's also fascinating, you touched on this earlier, are the social clues gleaned from Ardi's species.
Right, the sexual dimorphism, or lack thereof.
Yeah, the male and female individuals discovered within her species showed similar body sizes. Now, in the primate world, significant differences in size between males and females, what we call sexual dimorphism, are often linked to more competitive,
Often more aggressive.
and sometimes more violent social structures, where males might fight aggressively over access to females. Think gorillas, for example.
Right, the big silverback versus the smaller females.
But when males and females are similar in size, like in Ardi's species, it often points to more cooperative, less aggressive social dynamics, maybe even pair bonding or cooperative parenting strategies.
It's a subtle clue, but potentially profound.
This subtle detail tells us something potentially profound about Ardi's community life and the beginnings, perhaps, of more typically human social behaviors, even 4.4 million years ago.
Indeed. It suggests a potential shift away from the intense male-male competition seen in many primate species and towards a more pair-bonded or cooperatively breeding social system. This is a foundational aspect of later human societies where shared resources and collective child-rearing became crucial.
So maybe our social structures started changing early too.
This hints that early hominin social structures were evolving right alongside their locomotion, perhaps even influencing each other. The reduced aggression suggested by reduced sexual dimorphism could have freed up energy for other social investments, like cooperation or childcare.
But as you mentioned, the biggest impact of Artie's discovery was how it absolutely shattered what we call the old savanna theory.
Yeah, that was the big one.
For decades, the prevailing idea was that bipedalism evolved as early humans moved out of shrinking forests into expanding grasslands. The theory logically went that they needed to stand upright to see over tall grasses,
Spot predators?
spot predators, or maybe travel long distances efficiently across open plains under the hot sun. On the surface, it made a lot of sense. It was a very compelling narrative.
Seemed intuitive, right?
Yeah.
Trees disappear, you stand up.
Exactly.
However, Artie's features fundamentally contradicted that. Her anatomy strongly suggested that upright walking evolved in forested environments, or at least in mosaics of woodland and gallery forest, not out on the open savanna.
So she was walking upright among the trees.
It looks that way. The fact that she retained significant arboreal adaptations like grasping feet, yet possess a pelvis clearly adapted for bipedalism, paints a very different picture. She was a forest dweller who was experimenting with bipedalism within those same woodlands, not a savanna creature forced onto 2 feet by a lack of trees. Her discovery and the careful reconstruction of her paleoenvironment based on associated animal and plant fossils forced a complete rethink of the environmental context of bipedalism's origins.
So this fundamentally shifts our understanding of the initial selective pressures for bipedalism, doesn't it? It wasn't about escaping a treeless savanna.
Nope.
Instead, could it have been about maybe carrying resources like food or infants, freeing up the hands for other tasks even while foraging in a forest?
That's a strong possibility.
Yeah.
Carrying things is much easier on 2 legs.
Perhaps it improved vigilance not just over tall grasses, but within a denser forest, allowing better scanning for food or threats in a more complex 3-dimensional environment.
Could be. Or maybe reaching for fruit on lower branches.
Or maybe it was simply a more efficient way to forage both on the ground and in lower branches, allowing access to resources that 4-legged movement couldn't easily reach.
It suggests a complex interplay between arboreal and terrestrial life, where bipedalism was just one innovative solution among many, emerging for reasons far more nuanced than simply seeing over the grass.
It wasn't one simple cause.
That's the key takeaway. It forces us to think beyond simple single-cause explanations. Bipedalism wasn't a one-off adaptation to a solitary environmental shift. It was likely a complex response to a rich, diverse, and changing ecological niche where multiple advantages combine synergistically to favor upright posture. It highlights the truly experimental nature of early hominin evolution,
Experimentation again.
trying out different ways to exploit resources and move through varied landscapes.
So from the potential bipedalism of Toomai pushing the timeline and geography to Artie's definitive woodland walk, redefining the why and where of upright posture, we see the very early and diverse development of this foundational human trait. But when did it become truly definitive, unmistakable, an obligate way of moving? And what did that really mean for the next big evolutionary leap?
This takes us to the period where bipedalism became a thoroughly established primary mode of locomotion, a trait that was essentially locked in, no longer just facultative or experimental.
Right.
This was a crucial phase because it fundamentally rearranged the body plan, freeing up the hands consistently and setting the stage for subsequent evolutionary developments that would have truly profound consequences.
Okay, here's where it gets really interesting, I think, and starts to challenge our preconceived notions of evolutionary progress. Once our ancestors were firmly on 2 feet, a physical transformation that took millions of years to solidify what came next, specifically in terms of other distinctly human traits, like, say, brain size. And how did those fundamental changes, specifically the order in which they appeared, fundamentally shift our understanding of what actually makes us human?
That's a truly important question, and it speaks directly to our deep-seated biases, doesn't it? We often assume that brain size dictated everything, that a big brain led to all our other distinct traits, like tool use and bipedalism.
Brain first, everything else follows.
That narrative often places cognitive ability at the forefront of our evolution. But these next discoveries show us a very different evolutionary sequence, where key human characteristics emerged in, well, unexpected orders. This powerfully challenges our anthropocentric biases and forces us to reconsider our assumptions about linear progress in our own lineage.
And the undisputed superstar, the icon of definitive obligate bipedalism, is Lucy, Australopithecus afarensis.
Lucy, everyone knows Lucy.
Discovered in Ethiopia in 1974, dating to 3.2 million years ago, Lucy's skeleton was approximately 40% complete. Now, in the world of paleoanthropology, finding even a single hominin bone is a huge deal, right? Sparks immense excitement.
Absolutely. Finds are often very fragmentary.
So finding 40% of an individual skeleton from that far back in time, that's not just a significant find, it was a truly remarkable paleontological jackpot, giving us an unprecedented look at a complete individual from that era.
Lucy's extraordinary completeness allowed for an unparalleled level of analysis of her anatomy. Prior to her discovery, there were still ongoing scientific debates about the precise nature and extent of bipedalism in early hominins, like the Australopithecines.
Were they fully upright, or still partly in the tree?
Exactly. There was robust argument about whether they were truly obligate bipeds, or if they still spent significant time in the trees, maybe more than just for sleeping. Lucy provided irrefutable, concrete evidence that firmly settled many of those discussions. Her bones spoke volumes.
She was a bit over 3 feet tall, so quite small,
Diminutive. Yeah.
with relatively long arms, still hinting at some arboreal capabilities perhaps for climbing trees to sleep or escape predators. But crucially, she had a small ape-like skull.
Small brain case, that's key.
So while her body was adapting dramatically for walking, her brain hadn't significantly expanded yet. This is super important. But it was her pelvis and her leg bones that provided the definitive proof of how she moved.
The postcranial skeleton.
They showed clear, unambiguous adaptations for upright walking. This wasn't just possible bipedalism, like maybe in Tumai, or a facultative woodland biped like Ardi who could do both. This was an individual whose skeletal structure was optimized for moving efficiently and primarily on 2 feet. This was how she moved definitively across her landscape.
And Lucy's story is perfectly corroborated and complemented by other remarkable evidence. The famous Litoli footprints.
Ah, yes, the footprints in the ash.
Discovered in Tanzania by Mary Leakey in 1978, these fossilized tracks date to 3.6 million years old.
Even older than Lucy.
Exactly, actually predating Lucy herself by about 400,000 years, showing that her kind, Australopithecus afarensis, had been walking upright efficiently for a long time before her.
Wow.
These pristine footprints, preserved incredibly in volcanic ash, showed distinct heel-to-toe walking, just like modern humans, complete with an arch and a non-divergent big toe aligned with the others.
No grasping big toe like Artie's.
Nope. Fully committed to bipedalism. This provided conclusive corroboration that definitive, efficient bipedalism was well established even before Lucy's time. We have the skeletal evidence from Lucy and the direct behavioral evidence from the footprints, a truly powerful and undeniable combination that left no room for doubt.
This provided concrete evidence, really solid proof that walking upright came before significant brain expansion.
That's the bombshell.
This was a truly pivotal moment in paleoanthropology as it directly overturned older, deeply entrenched theories that had long posited large brains as the initial driver for bipedalism and other human traits.
The brain-first hypothesis.
The thinking used to be first you get smart, then you figure out how to walk upright, then you make tools. Lucy flipped that script entirely. Instead, it seems moving on 2 feet was a foundational physical adaptation that rearranged the entire body.
The skeleton changed first.
This then perhaps later freed up the hands for tool use and complex manipulation, which in turn could have spurred brain growth by encouraging complex problem-solving and innovation. The order of events was profoundly different from what we had assumed for so long.
It's a fundamental reordering of cause and effect in human evolution. Bipedalism wasn't a consequence of increased intelligence. It looks like it was the key enabling adaptation, a physical change that opened up completely new ecological and behavioral niches.
It's like freeing the hands.
Exactly, freeing the hands. And in doing so, it created the very selective pressures, maybe for tool use, maybe for carrying, maybe for social signaling, that eventually favored larger brains much later down the line. It wasn't about being smart enough to walk, it was the act of walking upright that fundamentally restructured our lives and paved the way for more sophisticated intelligence to emerge millions of years later.
It's an elegant example of how a simple physical change can have profound cognitive ripple effects. This discovery, in a way, forces us, and forces you listening, to reconsider what was truly important for our early ancestors. It wasn't about having a huge brain to start. It was about the physical adaptation of walking upright that paved the way for other forms of intelligence to develop. Think about it in your own life for a moment. What seemingly simple physical changes have you made? Maybe a new posture you adopted, a different way you organize your workspace, or even just making sure you get enough sleep that have unexpectedly led to massive cognitive or social shifts.
Hmm, that's a great way to think about it.
It's a powerful parallel for how seemingly basic physical adaptations can unlock entirely new ways of thinking and interacting with the world, proving that sometimes the physical literally paves the way for the mental.
It absolutely highlights the intricate feedback loop nature of evolution, where one adaptation, in this case bipedalism, can create the conditions and selective pressures for another, seemingly unrelated trait-like advanced cognition to flourish much later. It's a domino effect that spans millions of years.
So definitive upright walking came first, well before our brains got significantly bigger, upending a core theory. But if brain size wasn't the immediate driver for our foundational physical trait, and if complex behavior can predate it, what about other distinctively human complex behaviors? Could truly symbolic thought, intricate rituals, maybe even early forms of art emerge in species with surprisingly, almost shockingly small brains?
Ah, now you're getting to the really thorny stuff.
This leads us to one of the most astonishing and recent discoveries of our time.
This is truly where we confront our assumptions about human uniqueness and intelligence head on. The idea that complex cognition and symbolic behavior are exclusively tied to a large encephalization quotient, that is, a brain size significantly larger than what would be expected for an animal of a particular body size.
Basically, a big brain for your body size.
Exactly. That idea is deeply ingrained in our understanding of ourselves. But the evidence from this next species completely dismantles that notion, or at least seriously complicates it, forcing us to redefine intelligence itself.
Enter Homo naledi.
Naledi. Yes.
This species lived between, what, 335,000 and 236,000 years ago.
Relatively recent, geologically speaking.
In South Africa's incredibly challenging and remote rising star cave system,
There?
the discovery itself was epic, wasn't it? A testament to human daring and scientific collaboration.
Absolutely incredible exploration story.
It involved an almost unimaginable feat of tight-squeeze spelunking by a team of incredibly slender scientists, often referred to as underground astronauts,
Mostly women, actually, who could fit through the tiny gaps.
who risked their lives navigating passages sometimes just 7 inches wide just to reach the Naledi chamber where the bones were found.
Pitch black, dangerous, deep underground.
The sheer volume of fossils was staggering. Over 1,500 individual bones were recovered from at least 15 individuals, ranging from infants to elderly adults,
A whole population sample, almost.
representing a truly remarkable paleontological find from a single site. Unprecedented, really.
The fossil record is notoriously sparse and fragmented, as we know. So to uncover such a rich deposit, representing so many individuals of the same species and across a full age range, provided an unparalleled opportunity to understand their anatomy, growth, potential population dynamics, and even hints at their social structure. It's like finding a complete family album from hundreds of thousands of years ago.
But the most shocking fact about Homo naledi, the detail that absolutely floored the scientific community, was their incredibly tiny brains.
That was the real stunner.
Their average brain size was only about 500 cubic centimeters. That's roughly one-third the size of modern human brains, which average around 1,500 cc.
Tiny.
To put that in perspective, it's comparable to the brain size of an orangutan or even an Australopithecus, a much earlier, more ape-like ancestor like Lucy.
Right, like finding a species with a brain size from millions of years earlier, but living relatively recently and showing complex behaviors.
This immediately led many to assume they were a rather primitive species, intellectually speaking, certainly not capable of anything truly sophisticated. You see a small brain, you think simple behavior.
And this is precisely where the profound contradiction emerges, and where Homo naledi becomes so revolutionary. Conventional wisdom, as you said, dictates that such a small brain would absolutely preclude complex, coordinated behaviors, especially those involving abstract thought or ritual.
You'd think so.
Yet the context of their discovery, deep within a dark, dangerous cave system, tells an entirely different, astonishing story. This isn't just a challenge to our assumptions, it's a direct refutation of them, potentially.
Exactly. Despite those small brains, Homo naledi exhibited astonishingly complex, coordinated rituals that would typically only be associated with species like Homo sapiens or Neanderthals, species with brains 3 times the size.
What's the evidence for these rituals?
The evidence strongly suggests they deliberately carried their dead, repeatedly, deep into these almost inaccessible dark chambers of the cave system. This wasn't a natural accumulation of bones from animals dragging carcasses in or bones washing in.
So purposeful deposition.
It seems like it. A purposeful act requiring collective effort, significant memory, planning, spatial navigation in total darkness, and an understanding of death, perhaps even grief or respect for the dead.
That alone is remarkable for that brain size.
But it gets even more incredible. Even more recently, in 2023, startling evidence of deliberate burials, actual pits dug for bodies, and even geometric carvings like hash marks and cross-hatchings on the cave walls adjacent to these burial sites was announced.
Carvings. That implies symbolic thought.
This takes things to a whole new level, pointing towards advanced symbolic thought, the abstract understanding of patterns, and possibly even early forms of artistic expression or commemoration. This isn't just complex behavior, this is evidence of something akin to a spiritual or cultural practice.
This discovery, if the interpretations hold up, and again, there's always debate in paleoanthropology,
Sure, always.
but it profoundly challenges our very definition of consciousness, ritual, and symbolic thought. It suggests that these complex behaviors were not unique to large-brained species like Homo sapiens and Neanderthals, which is what we typically assume, tying our own cognitive success to sheer brain volume.
So brain size isn't everything.
Instead, Homo naledi completely separates the idea of cognitive capacity from absolute brain size, or at least complicates the relationship significantly. It indicates that perhaps neural organization, the density and connectivity of neurons, or other factors related to brain architecture might be far more crucial for complex behaviors than the sheer volume of brain matter.
How the brain is wired, not just how big it is.
Exactly. We've been looking at the wrong metric, maybe, or at least an incomplete one. Maybe efficiency matters more than size in some contexts.
It's truly mind-bending to consider. How did such a small-brained species manage the coordination, the memory for navigating a labyrinthine cave in total darkness, the planning required for repeated journeys, and the abstract thinking to intentionally inter their dead, let alone create abstract art on the walls?
It pushes the boundaries of what we thought was possible.
This opens up huge questions about the origins of spirituality, mourning, collective memory, and even the very nature of what we call intelligence. Could it be that what we perceive as intelligence manifests in incredibly diverse ways that we're only just beginning to appreciate?
Perhaps their intelligence was perfectly suited for their niche, for collective living and navigating their specific challenging environment, and we've been too narrow in our anthropocentric definitions focused on our own kind of smarts.
What does it mean if planning, empathy, and symbolic thought can arise in such a dramatically different neural package?
It forces us to acknowledge that there isn't a single monolithic path to intelligence or complex behavior. Evolutionary solutions can be highly varied. Homo naledi is a powerful reminder that our own definition of humanity might be far too restrictive if we base it solely on the size of the cerebral cortex.
We need broader definitions.
It suggests a spectrum of cognitive capabilities that we're only now starting to map, and it demands that we be more open-minded about what constitutes smart. It makes us wonder about the consciousness, the inner lives of other extinct hominin species too. What were they capable of?
Homo naledi truly shows us that our lineage wasn't just about gradual linear progress, where bigger brains always equaled more complex behavior. Instead, it was about different species experimenting with different combinations of human-like traits.
Like a pick and mix of features.
In surprising and often contradictory combinations. This leads us to zoom out and look at the bigger picture of our true family tree.
And this is precisely where the disparate pieces of the puzzle we've just discussed, Tumai, Ardi, Lucy, Naledi, begin to cohere into a grander, more accurate picture of our past. It's about recognizing that our past is not a story of singular success marching along a single line, but of multitudinous attempts, varied adaptations, and astonishing biodiversity within our own lineage.
So what does all this truly mean when we bring it all together? We've seen these incredible individual stories, Tumai pushing our timelines and geographical assumptions, Ardi rewriting bipedalism's environmental origins, Lucy solidifying its early dominance over brain expansion, and Homo naledi utterly challenging our very definition of intelligence and symbolic thought. But when we zoom out and connect all these dots, the biggest revelation, the overarching theme, is how messy, how experimental, and how utterly diverse our evolutionary past truly was.
If we connect this to the bigger picture, it's abundantly clear that human evolution wasn't a singular march forward along that imagined ladder. It was instead a dynamic, sprawling network of different species, often coexisting for vast periods of time.
Living at the same time in the same places sometimes.
Absolutely. Each was trying out their own unique solutions to the challenges of survival, adapting to shifting environments and exploring different physiological and behavioral pathways. This isn't a neat sequential progression. It's a vigorous, competitive, and highly creative process of trial and error played out over millions of years.
That's right. Early human evolution was emphatically not linear, like a simple chain where one species replaced the last in an unbroken line to us. Instead, it was a complex, branching, and highly experimental process, more like a dense, tangled shrub or that thicket we mentioned, than a ladder.
A bushy tree of life.
For millions of years, multiple early human species lived side by side, sometimes in the same environments. They weren't just sequential steps, they were contemporaries, each representing a different evolutionary experiment, with various traits and strategies all existing in parallel. This biodiversity in our own lineage is a profound concept to grasp.
And these diverse branches explored a remarkable range of survival strategies and adaptations, truly showcasing evolution's capacity for innovation. Let's just quickly recap some of these solutions we've highlighted.
Okay.
Upright walking. We saw this emergent trait in various forms and contexts. Tuae, 7 million years ago, offered the first hints,
The earliest potential clue.
suggesting an incredibly ancient origin, though still debated. Then Ardi, 4.4 million years ago, demonstrated a form of facultative bipedalism, able to walk upright on the ground in woodlands while retaining grasping feet for tree climbing, completely upending the savanna theory.
The woodland walker.
Finally, Lucy, 3.2 million years ago, represented definitive obligate bipedalism, with a pelvis and leg structure unequivocally designed for efficient two-legged locomotion, an adaptation that became foundational well before any significant brain expansion. Each represents a different phase or context of this critical adaptation.
Different ways of being bipedal, almost.
Then, cooperative social life. We saw hints of this with Ardi, where the reduced sexual dimorphism suggested a move away from intense male-male competition towards potentially more pair-bonded or cooperatively breeding social systems.
A subtle but maybe crucial shift.
A subtle but profound shift, as cooperation is such a hallmark of later human societies. It suggests that our complex sociality has deep roots.
And then the big one recently.
And then symbolic rituals and complex cognition. Most dramatically, the symbolic rituals of Homo Naledi, deliberate disposal of the dead, perhaps even burials, and abstract cave carvings shattered our assumptions about the cognitive prerequisites for such behaviors.
With that tiny brain.
With that tiny brain. It demonstrated that sophisticated abstract thought and ritualistic practices were not exclusive to large-brained species like Homo sapiens, forcing us to reconsider the neural architecture required for these capacities.
And while not explicitly detailed in our specific sources today, it's worth remembering that tool use was another critical part of this broader experimental toolkit, right? Developing alongside, and sometimes even before, some of these other changes.
Absolutely. Tool use is another huge part of the story, developing over millions of years, becoming increasingly complex. That's another whole deep dive.
The point is, there were so many different ways to be a hominin. In fact, the latest 2024 discoveries in Ethiopia further underscore this complexity, revealing that early humans coexisted in intricate ways that we are only now beginning to grasp.
The picture keeps getting richer and more interwoven.
It suggests a bustling, ancient world filled with different kinds of humans, all vying for survival and trying out different life strategies simultaneously.
This view fundamentally challenges the traditional progress narrative, where each species was simply an improved version of the last, leading inevitably, inexorably, to Homo sapiens.
Like evolution had us in mind all along.
Which it almost certainly didn't. Instead, this branching view highlights resilience, ecological niche partitioning, which basically means how different species found unique ways to share and utilize the same environment without directly outcompeting each other immediately.
Finding their own little corners.
And the sheer variety of ways to thrive.
Yeah.
Many of these branches, of course, simply died out. They were evolutionary dead ends in terms of direct lineage to us. But their existence tells us so much about the sheer breadth of evolutionary possibility and the constant relentless drive of life to adapt and innovate, exploring every conceivable avenue. It's a humbling thought, really, that our path was just one among many, many others.
It truly is a powerful lesson in diversity. Think about how diverse human cultures are today, with thousands of languages, customs, and ways of life. Our evolutionary past was even more diverse at a biological level.
Multiple species, not just cultures.
It's a powerful reminder that there's no single right way to be human, and that diversity has been a hallmark of our lineage from the very beginning. It's a story of constant exploration and adaptation, not a predetermined march towards a single ultimate form. We are the survivors, the descendants of just one of these countless evolutionary experiments.
And this leads us, I think, to the most profound insight this deep dive offers, which fundamentally redefines the deeper meaning of human.
Absolutely. The core information, the key takeaway from all of this, is that being human is not defined by a single isolated trait like superior intelligence or tool-making abilities, or even just walking upright alone.
It's not one magic bullet.
Instead, the truly unifying characteristic that defines our entire lineage across these millions of years, from the earliest potential biped like Tumai right up to us today, is experimentation and adaptability. It's our lineage's inherent, insatiable drive to continuously try new things and adjust to changing circumstances.
It's this constant trying out of new strategies, this flexibility, not the eventual perfection of a single one, that truly marks our evolutionary path. It's the willingness to iterate, to discard what doesn't work, and to relentlessly pursue new ways of engaging with the world. This is the thread that connects all these diverse species we've talked about.
Let's just quickly synthesize this across the incredible species we've discussed. Tumai's unexpected location and potential bipedalism showed us an incredibly early adaptation to a vast, unknown environment, immediately putting bipedalism on the evolutionary table as an option.
Experiment number one, maybe.
Artie's unique blend of tree climbing and upright walking demonstrated a novel solution for woodland life, directly challenging and ultimately overturning long-held theories about the why of bipedalism. Another experiment.
A different approach to locomotion.
Lucy's definitive bipedalism, crucially preceding significant brain expansion, was a fundamental physical experiment that freed up the hands and unlocked entirely new possibilities for behavior, resource manipulation, and eventually perhaps for bigger minds.
A foundational shift.
And Homo Naledi's small brains and complex rituals proved that symbolic behavior wasn't just for the big-brained, fundamentally expanding our understanding of intelligence itself, forcing us to look beyond simple metrics. A cognitive experiment, almost.
Each of these was an evolutionary exploration, pushing boundaries. The undeniable thread connecting all these diverse branches from 7 million years ago right up to today is that relentless drive to innovate and explore new ways of living, new ways of interacting with the world, and new ways of connecting with each other. It's an inherent defining characteristic of our entire hominin lineage, a continuous biological and cultural exploration.
This reframes our understanding of human success, doesn't it? It wasn't about finding the single perfect solution and sticking with it for all time.
Evolution doesn't really work like that.
Instead, it was about continuously trying different solutions, adapting to rapidly changing environments, climate shifts, new predators, new opportunities, and pushing the boundaries of what was possible in terms of locomotion, social structure, diet, cognition. This experimental mindset, this willingness to adapt and pivot, this constant biological creativity, is arguably our most enduring and defining legacy as a species.
It's what allowed our ancestors, and ultimately our species, to survive and thrive through immense environmental and social changes when so many other branches of that sprawling bush withered away. Adaptability is key.
And it continues to define us today, right?
Absolutely. We are, by our very nature, problem solvers and innovators, driven by this same ancient impulse to adapt and experiment. Our current technological and social revolutions are simply the latest manifestation of this deep evolutionary imperative that's been running for millions of years.
We've journeyed through millions of years today, exploring these groundbreaking discoveries that reveal a far richer, more experimental, and frankly more surprising story of human origins than many of us ever imagined. We've seen that our family tree isn't a straight, predictable line, but a vibrant, branching network of innovation, filled with remarkable detours and diverse forms of ingenuity. It truly makes you reconsider your own place in this grand, unfolding narrative.
It's a powerful testament to the power of natural selection, and maybe other evolutionary forces too, to sculpt a myriad of forms, each uniquely adapted, at least for a time, to its particular niche. Some of these adaptations ultimately led down the path to us, Homo sapiens, but many others represent equally valid, equally ingenious, albeit now extinct, paths in the grand experiment of being a hominin. The past truly informs our present and maybe hints at our future.
So, considering this long, rich history of experimentation and adaptability, this relentless drive to innovate that seems woven into the very fabric of our being, here's a final thought for you. What new experiments are we conducting as a species today?
Hmm, that's a big question.
From our explosion of digital communication and virtual realities that are fundamentally reshaping our social interactions, maybe even our brains, to the incredibly rapidly advancing fields of genetic engineering and artificial intelligence that promise to redefine life itself. How might our current adaptations, both biological and technological, be viewed by future paleontologists or maybe future historians millions of years from now?
What branch are we creating now?
Exactly. And what other incredible branches of our family tree are still waiting, buried deep in the earth, ready to be discovered and redefine our past and future once again?
The questions are endless, and the answers are still being unearthed, sometimes literally. It's a story that continues to evolve, just as we do, a living, breathing testament to the power of adaptation and that constant, restless experimentation.